Let's think about hydrocarbon combustion in terms of a chem quiz. I'm going to take a hydrocarbon, burn it in oxygen, and take the product, inject it into my mass spectrometer, and generate a mass spectrum. The question I have is, which of these hydrocarbons would give this mass spectrum after reaction with oxygen? Think about that for a second and make a selection. Let's consider an explanation for each of the three options. Option A, each methane molecule reacts with two oxygen molecules, giving a 1:2 mass ratio in the mass spectrum. B, ethylene, C2H4, has a 1:2 ratio of atoms, which is the ratio shown in the mass spectrum. Or C, acetylene, C2H2, and oxygen will produce 2 CO2 molecules for every 1 H2O molecule, giving a 2:1 ratio in the mass spectrum. Think about those possible arguments and make another selection. Let's look at each of those hydrocarbons, their reaction with oxygen, and the mass spectrum of the products. So the first is methane. If we react methane with oxygen, the balanced chemical reaction would tell us 2 water molecules and 1 carbon dioxide molecule were formed. So that mixture in the mass spectrum would give a 2:1 peak height ratio, where the water would give a peak at 18 of twice the height of the carbon dioxide at 44. If we look at the ethylene, again, balance the chemical reaction, we find equal amounts of carbon dioxide and water are formed. So the mass spectrum of the products would show a 1:1 peak height at 18 and 44 from the carbon dioxide in the water. The third possibility, acetylene, has 1 water molecule and 2 carbon dioxide molecules formed in the balanced chemical reaction with oxygen. That would give us a peak at 18 and a peak at 44 of twice the height. So indeed, acetylene with the 1:2 peak height ratio was the hydrocarbon that was burned in this experiment.